Hi everyone. Today we're going to study the quartiles. In the end, we're going to have an example how to compute the first quartile. Let us first define the quartiles. The quartiles are the score points which divide a distribution into 4 equal parts. To illustrate, I have here a line representing the distribution. The first quartile is here, denoted by Q sub 1. We say that 25% of the distribution fall below the first quartile. The second quartile is here in the middle. This is denoted by Q sub 2. We say that 50% of the distribution fall below the second quartile. The second quartile is equal to the median. The third quartile is here, denoted by Q sub 3. We say that 75% of the distribution fall below the third quartile. Let us study the formula of the quartiles. Let's begin with the second quartile, and we say that this is equal to the median. Let us write the equation of the median, and that is the same equation for the second quartile. This is the formula: x sub LB plus n over 2. This quantity here represents 50% of the distribution, minus CF sub P, all over F times the quantity I. For the first quartile, it will be almost the same with the second quartile formula, except on this part. Take note, for the second quartile, this is n over 2. For the first quartile, we write n over 4. And this n over 4 represents 25% of the distribution. For the third quartile, it will be almost the same formula, except on this portion. For the third quartile, we write 3n over 4. This value represents 75% of the distribution. So the Q sub 1, Q sub 2, and Q sub 3 are the quartiles. The x sub LB is the lower class boundary of respective quartile class. The n is the total number of cases. CF sub P is the cumulative frequency of the class preceding the quartile class. The F is the frequency of the quartile class, and I represents the class width. Let us see this example. Find the first quartile of the distribution below. We have 1, 2, 3, 4, 5, 6, 7 classes. And this is the column for the frequency. There's a frequency of 2 for the first class, 1 to 9. A frequency of 6 for the class interval from 10 to 18. And frequency of 9, 10, 12, 7, and 4 respectively. Next thing to do is we can write the total of the frequency, and that is our n. This is equal to 50. Next, we need a column for the cumulative frequency, denoted by CF. The values are here. The first value is 2, which is copied from the frequency of the first class. So this number 2 plus 6 is 8. So we write here 8. 8 plus 9 is 17. 17 plus 10 is 27. 27 plus 12 is 39. 39 plus 7 is 46. 46 plus 4 equals 50. The last number of the CF column must be equal to the total number of cases. Let us now write the first quartile formula. And for step 1, we will find the first quartile class. Find the value of this n over 4. The n equals 50 divided by 4, and this is 12.5. We're looking for the 12.5 item. In this example, the first quartile class is where this 12.5 item lies in the CF column. Let us go to the CF column, and we can see that the numbers are growing bigger as we go down. The 12.5 item is found in the third class. So we say that the first quartile class is this 19 to 27. For step 2, let us collect the required values. Let's begin with the n over 4 that we get from step 1, that is 12.5. The x sub lb is the lower class boundary of the first quartile class. We write here 18.5. We got this value from the lower limit 19 minus 0.5. So we write here 18.5. The CF sub p is the cumulative frequency of the class preceding the first quartile class. For the CF column, the preceding cumulative frequency is 8. So we write here 8. Next is F, that is the frequency of the first quartile class, and this is equal to 9. I is the class width. It means the number of items inside a class interval inclusive. So this 10 to 18, if you count all numbers included here, you will see that there are 9 numbers for this class. In fact, in all the classes. So I equals 9. For step 3, substitute the values in the formula and solve. So the x sub lb equals 18.5 plus the n over 4 is 12.5 minus the CF sub p is 8 all over the f, that is equal to 9, times I, which is equal to 9 also. Simplifying further, the 12.5 minus 8 is 4.5. And this 9 and 9 can be cancelled out. Simplifying, we have now 4.5 here. And this value is added to 18.5, so we have q sub 1 equals 23. We say that 25% of the cases or the distribution scored below 23. This is our final answer. Find the third quartile of the distribution below. In our distribution, we have 1, 2, 3, 4, 5, 6, 7 class intervals. This is the column for the frequency. There is a frequency of 2 for the class interval from 1 to 9. A frequency of 6 for the class 10 to 18. Also, we have 9, 10, 12, 7, 4 frequencies respectively. We can now compute for the total number of frequency, and that is the n. This is equal to 50. Construct another column that is cumulative frequency, denoted by CF. The terms are here. This number 2 is copied from the frequency of the first class. So 2 plus 6 equals 8. So we write here 8. 8 plus 9 is 17. 17 plus 10 is 27. 27 plus 12 equals 39. 39 plus 7 is 46. 46 plus 4 equals 50. The last number here must be equal to the total number of frequency. Let us now write the formula for the third quartile. Now, let us do the step 1. That is to find the third quartile class. Let us get this portion here, the 3n over 4, and let us find this value. We substitute the value of n as 50, so we have 3 times 50 divided by 4. The product is 150, and this is now divided by 4, so we have 37.5. We are looking for this 37.5 item. We say that this 37.5 item lies in the third quartile class. For step 2, we shall locate this 37.5 in the CF column, the cumulative frequency. Here is the cumulative frequency column. We can see that the numbers grows bigger as we go down. Looking for the 37.5, we can see that it belongs to this class. So this class 37 to 45 is the third quartile class. For step 3, let us collect the required values. We started with 3n over 4 from step 1, and we know that value is 37.5. Next is the x sub LB. This is the lower class boundary of the third quartile class. We write here 36.5. We got this value from the lower limit of the class. This 37 minus 0.5 is 36.5. The CF sub P is the cumulative frequency of the preceding class. Here, the CF of the third quartile class is 39 and the preceding value is 27. So we write here 27. The F is the frequency of the third quartile class. This is the number 12 that we copied here. I is the class width, and this is equal to 9. It means for every class here, there are 9 numbers included. For step 4, we substitute the values in the formula and solve. The x sub LB is now 36.5 plus the 3n over 4 is 37.5 minus the CF sub P, that is now 27, all over the F, which is 12, times the quantity I, which is equal to 9. Simplifying further, the 37.5 minus 27 is 10.5. And then let us multiply this 9 to the numerator. We will get the 94.5. We simplify this fraction into 7.88. And the sum of 7.88 and 36.5 is the third quartile value, which is 44.38. We say that 75% of the distribution scored below 44.38, and that is the third quartile. This is the final answer. Hi everyone. Today we're going to study the deciles. Let us define the deciles. The deciles are the score points which divide a distribution into 10 equal parts and are denoted by d sub 1, d sub 2, d sub 3, up to d sub 9. The d sub 1 value denotes that 10% of the distribution fall below it. For d sub 2 means 20% of the distribution fall below it. For d sub 3, it means 30% of the distribution fall below it. D sub 4 means 40% of the distribution fall below it. D sub 5 means 50% of the distribution fall below it. I hope you can see a pattern on this. This pattern continues to d sub 6, d sub 7, d sub 8, and the d sub 9 means 90% of the distribution fall below it. Let us see now the formulas for the deciles. It is said that deciles are computed in much the same way as how the median, quartiles, and percentiles are calculated. Here are the formulas for d sub 1, d sub 2, d sub 3, d sub 4, and d sub 5 respectively. I hope you can see the pattern here. This is much the same way of the formula for the median. The only difference is this portion here. For d sub 1, this is 1/10 times n. For d sub 2, 2/10 times n. For d sub 3, this is 3/10 times n. D sub 4, 4/10 times n. And d sub 5, 5/10 times n. Take note that the x sub lb is the lower class boundary of the decile class. The Cf sub p is the cumulative frequency of the preceding class. The f here is the frequency of the decile class, and the I is the class width. Take note that when we simplify this portion, this formula here is exactly the same formula of the median. So d sub 5 is equal to the median. To complete the formulas, we have the d sub 6, d sub 7, d sub 8, and d sub 9 formulas in here. Let us see this example. Find the 7th decile of the distribution below. We have two columns here. The first column for the class intervals, and we have 7 classes here. The second column is for the frequency, and the respective frequencies are also written. Now, for our first step, let us compute for the total number of frequency, and that is the n. This is equal to 50. Let us construct another column, and that is the cumulative frequency denoted by Cf. The values are here. The first number here, the number 2, is copied from the frequency of the first class. And then 2 plus 6 equals 8. So we write here 8. 8 plus 9 is 17. 17 plus 10 equals 27. 27 plus 12 equals 39. 39 plus 7 equals 46. 46 plus 4 equals 50. The last value here must be equal to the total number of frequency. Now let us write the formula for the d sub 7. Now for the step 1, let us find the 7th decile class. Let us compute for this value 7/10 times n. Substituting the value of n, we have now 7/n times 50. The product of 7 and 50 equals 350. And divided by 10, we have 35. We are looking for the 35th item to find the d sub 7 class. We say that the 35th item lies in the d sub 7 class. Step 2, let us locate this 35th item in the Cf column. Take note that our numbers for the Cf column is increasing as we go down. Looking for the 35th item, it belongs in this class. So we say that the 37 to 45 is the 7th decile class. For step 3, let us collect the required values of the formula. We started with a value 7 over 10 times n from step 1. This is equal to 35. Next is the x sub lb, the lower class boundary of the d sub 7 class. We write here 36.5. We got this value from this class. The lower limit is 37. We subtract by 0.5. So the answer is 36.5. Next is the CF sub P. This is the cumulative frequency of the class preceding the D sub 7 class. And this is 27. Next is the F. This is the frequency of the D sub 7 class. This is the number 12. I is the class width, and this is equal to 9. This number 9 is the number of terms or numbers inside a class. So in all the classes, there are 9 numbers included. For step 4, let us substitute the values in the formula and solve. X sub lb now becomes 36.5 plus this value 7 over 10 times n is 35 minus CF sub p equals 27 all over the f is now 12, and this fraction is multiplied by I, and we put here the number 9. Simplifying further, we can take the difference of 35 minus 27. So we have the number 8. Then we multiply 8 by number 9. So we have 72 over 12. Simplifying this fraction, the quotient is 6. So we add 6 and 36.5. The answer is the 7th decile, that is equal to 42.5. We said that 70% of the distribution fall below this value, 42.5, which is the 7th decile. This is our final answer. Today we're going to study the percentiles. Let us define the percentiles. The percentiles are the score points which divide a distribution into 100 equal parts and are denoted by P sub 1 for first percentile, P sub 2 for second percentile, P sub 3 for third percentile, up to P sub 99 for the 99th percentile. They are generally used to characterize values according to the percentage below them. For example, the 15th percentile, denoted by P sub 15, separates the lowest 15% from the other 85%. Let us discuss percentile ranks. Since the various measures of location differ in terms of the percentages of cases below them, it might be interesting to find out how these percentages, called percentile ranks, denoted by PR, are computed when percentiles are given. Percentiles are score points, while percentile ranks are percentages. In the statement 45% are less than 80, 80 is the percentile, and 45 is the percentile rank. Therefore, 80 is the value at the P sub 45, or the 45th percentile. Let us see now the formula for the percentiles. Percentiles are computed in much the same way as how the median, quartiles, and deciles are calculated. This is the formula. P sub PR equals X sub LB plus the ratio PR over 100 multiplied by N minus CF sub P all over F multiplied by I. Take note that this X sub LB is the lower boundary of the percentile class. The CF sub P is the cumulative frequency of the class preceding the percentile class. This F here is the frequency of the percentile class, and I is the class width. The N here is the total number of cases. Take note that the 50th percentile is equal to the median, which is also equal to the second quartile, and also equal to the 5th decile. Let us see this example. Find the 65th percentile of the distribution below. We have here two columns. The first column for the class intervals, where there are 7 classes. For the frequency, the numbers are here respectively. The first thing that we can do is to compute for the total number of frequency, and that is the N, which is equal to 50. Let us now construct another column for cumulative frequency, denoted by CF. The numbers are here. This number 2 is copied from the frequency of the first class, and 2 plus 6 equals 8. So we write here 8. 8 plus 9 is 17. 17 plus 10 equals 27. 27 plus 12 equals 39. 39 plus 7 equals 46. 46 plus 4 equals 50. The last number here must be equal to the total number of frequency. Let us now write the formula for the 65th percentile. We can see here that this is 65 over 100, representing the 65% of the distribution. For step 1, let us find the P sub 65 class. Getting this value here, let us substitute the value for the N. So this is now 65 over 100 times 50. we can cancel out this 50 and the 100. So we have 65 over 2, and that is equal to 32.5. This is the 65% of the distribution. So we are looking for the 32.5 item. We say that the 32.5 item lies in the P sub 65 class. For step 2, we locate the 32.5 value in the CF column. This is the CF column. We can observe that the values grow bigger as we go down. We are looking for this 32.5 in this column, or a number that is slightly higher. We can see that it is here. And this 37 to 45 is the P sub 65 class. For step 3, let us collect the required values of the formula. We started with that 65 over 100 times n from step 1, and the value is 32.5. X sub LB is the lower class boundary of the P sub 65 class. We write here 36.5. We got this value from the lower limit minus 0.5. So 37 minus 0.5 is 36.5. Next is the CF sub P. This is the cumulative frequency of the class preceding the P sub 65 class. Here is 27, so we copy it here. F equals 12. That is the frequency of the P sub 65 class. I is the class width. It is the number of terms or numbers inside a class. For step 4, let us substitute the values in the formula and solve. The X sub LB is now 36.5 plus this value here is the 32.5 minus CF sub P is 27 all over F, which is now equal to 12. This fraction is multiplied by I, and we substitute the value of 9. Let us simplify further. Let us take the difference of the numerator. 32.5 minus 27 is 5.5. Then we multiply this 5.5 with the number 9. So we have 49.5 divided by 12 equals 4.13. We add this value and the 36.5, we will get now the 65th percentile, which is equal to 40.63. We say that 65% of the distribution fall below 40.63. This is our final answer. Today we're going to study box plot and outliers. Let's begin with the definition of box plot. A box plot is a standardized way of displaying the distribution of data based on a 5-number summary. The 5 numbers are minimum, first quartile, median, third quartile, and maximum. Take note that the minimum is not the lowest value. Also, the maximum is not the highest value. We shall have a formula for this later. Boxplot can tell you about your outliers and what their values are. We will define outliers later. Boxplot can also tell you if your data is symmetrical, how tightly your data is grouped, and if and how your data is skewed. For illustration, we have here a line segment and the 5 numbers are here. The middle number is the median. At endpoints are the minimum and maximum values respectively. In the middle of minimum and median, the first quartile is written. Between median and maximum, here is the third quartile. Let us introduce to another term, interquartile range, or IQR. The formula is third quartile minus first quartile. After we get the IQR, we shall have now the formula for the minimum value. This is first quartile minus 1.5 times IQR. For the maximum, we have here third quartile plus the product 1.5 and IQR. Any value below minimum or above maximum is called an outlier. As defined, an outlier is an extremely high or extremely low data value when compared with the rest of the data values. Let us see this example. Draw box plot and check for outlier data. Here are the data. For our solution, the step 1 is, let us rearrange the values in ascending order. So we have here the lowest data as 3 and the highest value is 70. Now the box plot is here. In the middle is the median, the minimum and the maximum at endpoints. First quartile is here and third quartile also. We know that the median is the middle value, that is 26. So we write that value in the middle. On the left side of the median, we will take the middle value of this group, and that is the number 13. This is the first quartile. On the right side of the median, we will take the middle value of this group, and that 35 is the middle value, and we call it the third quartile. So we write that value here. Now, let us compute for the interquartile range, or the IQR. Our formula, third quartile minus first quartile. So we have 35 minus 13, and this is equal to 22. Now let us solve for the minimum and maximum. Let's begin with the minimum. So we have the first quartile, which is 13, minus 1.5 times the IQR, which is 22. The product 1.5 and 22 gives 33. So 13 minus 33 is negative 20. Let us copy this value below the minimum. Now for the maximum, we have the third quartile, that is 35, plus the product 1.5 and IQR, which is 22. This 1.5 times 22 is equal to 33. The sum of 35 and 33 is 68. This is the maximum. Let us copy this value below the maximum here. Now, let us look for outliers. We can observe in our data here that there is no value below the minimum. Also, there is one value above the maximum, and we call that an outlier. That value is the number 70. Again, we say that this is our box plot and we have an outlier here. This is our final answer. Today, we're going to study standard normal distribution and z-scores. Let us begin with normal distribution. Most of the continuous random variables, such as heights of adult men or women, have distributions that are bell-shaped, and these are called approximately normally distributed variables. Normal distribution is presented by the normal curve. This is the normal curve. Here now is the standard normal distribution. The standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. This is an example of a standard normal distribution. The mean is at the center with value 0, and the numbers going to the right are 1, 2, 3 respectively, while on the left we have -1, -2, -3. Take note that the interval between two numbers here is equal to the standard deviation. Normal distributions can be transformed to standard normal distributions by the formula z equals capital X minus mu all over sigma. The z is the z-score. The capital X is a score in normal distribution. Mu is the mean of normal distribution, and sigma is the standard deviation of the distribution. The standard normal distribution is sometimes called the z distribution. Let us have this example. Here is a normal distribution. The mean is at the center at 1010. Sigma, or the standard deviation, equals 20. In here, the interval of the numbers are measured by the standard deviation. The center at 1010, the next number is 1030. The next is 1050. And the last is 1070. The same pattern follows on the left side. On the left of the mean is 990. Next is 970. And the last number here is 950. So we can observe that the interval is of this value, which is the standard deviation 20. We can transform this normal distribution into standardized normal distribution. The mean will be equal to 0, and all these numbers will correspond to z value into 1, 2, 3 respectively. And on the left side, -1, -2, and -3. Let us see this example. Find the z-scores for the following x values given that mu, or the mean, equals 40 and sigma, or standard deviation, equals 5. Letter A, 48. B, 40. C, 30. Let us now write the formula of the z, that is capital X minus mu over sigma. Let's begin with problem A. X equals 48. So we have here z equals that 48, we write here, minus the mu is 40 over the sigma 5. Simplifying this, 48 minus 40 becomes 8, and this is divided by 5, so we have 1.6. Next is letter B, that value 40. So we have z equals 40 minus 40 divided by 5. 40 minus 40 is 0, divided by 5 is simply 0. Letter C is 30. So the z equals 30 minus 40 all over 5. The difference on the numerator is -10, divided by 5 is -2. So these values of z, we're going to write to each of the problems here correspondingly. Here we go. Now, let us show the z value in a standard normal distribution. We have the mean as 40 corresponding to 0 in the standard normal distribution. So let us begin with letter A. The z equals 1.6 for the x value 48. So here is the 1.6 and the 48 is here. So 48 is on the right of the mean. Letter B is 40. So the z equals 0. So the x value 40 is the same value with the mean. So the z equals 0. Next, letter C, z equals -2. -2 is here. So that is where the value 30 lies. With the figure here and with this example, we can deduce some conclusions. So let us remember, when z-score is positive, the x value is above the mean, just like with the number 48. When z-score is negative, the x value is below the mean. And this is reflected by our example when x equals 30, corresponding to z-score as -2. While when z-score is 0, the x value is equal to the mean, just like our example x equals 40. I hope you learned something from this video. See you again next time.